Hello, welcome to The Naked Scientists with me, Chris Smith, and also with Kat Arney.
Hello, and this week we're taking a closer look at norovirus. Not too close though, it's the so-called winter vomiting bug which affects up to 1 million people in the UK every year. Plus, in the news, the growth factors that could help wounds heal more quickly and the stress hormones that might be affecting the stock market.
The Naked Scientists podcast is powered by ukfast.co.uk.
And each week we also pose you a scientific teaser. And because we're talking norovirus this week, we thought we'd ask you, if a norovirus was scaled up to be the size of a grapefruit, how big would the corresponding person it was going to infect actually have to be? If you'd like to speculate, then the email address is chris@thenakedscientist.com and the Twitter address is @nakedscientists. First up, this week Cambridge scientists have discovered that chronic stress makes people much less likely to take risks, which could have a depressing effect on the stock market. John Coates is from the Judge Business School and is with us to tell us about the study he's done. Hello, John.
Hello.
Why were you doing this?
Well, I'm a former trader myself. I worked on Wall Street for about 13 years, and I really had a strong hunch while working there during some periods of financial turmoil that the bodies of traders were playing a far bigger role in the decisions they made than economics and finance had really appreciated. So there's this belief in finance and economics that financial decision-making is a purely cognitive activity. I don't think it is. I think risk-taking involves our entire body and brain working together. So we're looking at the way things like stress hormones affect financial risk-taking.
When you first began looking at this, it was actually at the time of the global financial crisis in 2007-8, and you said that perhaps stress may have a long-term dampening effect on markets. Is that what you've been exploring in this new publication?
Yeah, we've been doing a series of studies. We're trying to combine field work with lab work, which is, a spectrum of studies that you get in mature biological science. You don't find that so much in economics. But in the field work we've been conducting on trading floors in the City of London, where we've been sampling stress hormones from traders, we found in one of these studies that when the volatility went up in the market, in other words, when uncertainty went up in the market, the stress hormones followed it almost tick for tick. And in one of these studies, stress hormones on the trading floor rose 68% over a 2-week period as the volatility of the market increased. We sort of asked ourselves, my colleagues in the Department of Medicine at Cambridge said, 68% increase in cortisol over 2 weeks, that's going to start having effects on the brain and the body. So what we did was we went back to Addenbrooke's Hospital and we replicated that hormone profile in a group of volunteers, gave them a risk-taking task, and what we found is that the chronic stress caused their risk preferences to more or less collapse.
What was the hormone that you were manipulating?
It was cortisol, which is the main stress hormone produced by the adrenal glands, which sit on top of your kidneys.
So you elevate the cortisol levels in this group of volunteers who are not traders in this instance, they're just normal volunteers, and you're saying that their choice of whether they want to take a risk or not changes in response to that elevated cortisol?
Correct.
In what way does it change?
They become much more risk-averse. When given the opportunity to choose between gambles, in other words, if you had a choice between flipping a coin, which would give you 100 pounds if head came up, zero if zero came up, your expected return from that gamble is 50 pounds. If people would prefer to take 25 pounds for certain rather than play that game, then they're very risk-averse. And so you can measure people's risk preferences by, the amount of money they would take for certain rather than take chances on making a lot more money. And we found that under placebo conditions, people would, say on one bet, would prefer 40 pounds for certain, and then when they were chronically stressed, it might drop down to 25 pounds. So they're becoming very much more risk-averse.
So this suggests that these people at Addenbrooke's Hospital, if their performance were extrapolated to what's going on the stock market, then traders may be becoming a lot more risk-averse under high volatility, high market uncertainty conditions. So what would be the long-term impact on the markets then?
Well, we think what happens, the volatility and uncertainty in the market spikes most dramatically during crises. And we think what happens is that this mechanism that we've uncovered, the effect of chronic stress, not acute, but chronic stress in promoting risk aversion, it may be a physiological mechanism that morphs a bear market into a crash or a crisis. So that, for example, during the credit crisis a few years ago, when volatility spiked to astronomical levels and stayed there for a year and a half, we think the financial community, under the influence of stress hormones, became pathologically risk-averse. They just would not buy risk assets, no matter how attractive they became. And that meant that the financial community could no longer perform the task allotted to it, which is to buy cheap assets and stabilize the markets. They couldn't do it. The central banks had to step in and do it for them with these quantitative easing programs.
Does this mean then that before I make an investment on the stock market, I should be phoning up my broker and asking for a sample of testosterone and also for a sample of saliva to look for their cortisol to see whether they're likely to make risky bets or not?
Well, there's probably other ways of doing it, but it sounds far-fetched. But to tell you the truth, it's what sports physiologists do all the time with their athletes.
John, we must leave it there, but thank you very much for joining us. John Coates is from the Judge Business School in Cambridge, so there you go. Phone your broker and ask for a saliva sample to see if their cortisol levels are elevated. If they are, they might be somewhat risk-averse.
Are you a baseball fan, Chris?
I've been to a few baseball games. Every time I go to the States, I try and catch one. I can't say as I know all the players, but I do know some of the rules.
Well, I'm not a fan, and I think it's probably kind of up there with cricket in sports I don't want to watch. But now there's an intriguing paper from Aaron Seitz and a team at the University of California, Riverside. They've published it this week in the journal Current Biology. And it looks like brain training exercises might be the way for baseball players to gain an edge over the opposition. And in the case of the Riverside baseball team that they've tried this on, the benefits seem to have added up to maybe winning an extra 4 or 5 games over their whole season.
Wow, what do they do?
Well, in particular, the researchers are focusing on improving the player's vision. And a lot of previous research into visual acuity has tended towards visual exercises that just work out the muscles of your eyeballs, rather than actually going, does this make you any better at real-world tasks? So for their experiments, the researchers took 27 of the Riverside baseball male team before the start of the 2013 season. They made 19 of them do 30 lots of 25-minute visual training. This was using a special video game. And as a control, 18 teammates didn't get to play the game. Now, it sounds like fun for the guys who did get to spend all their time playing a video game, but it did really seem to make a difference. Now, the players who did the training, they saw an average 31% improvement in the accuracy or the acuity of their vision. This is like being able to see more letters on an optician's chart, and they had greater sensitivity to contrast in light. But more importantly, this translated out of the lab and onto the baseball field. And the trained players apparently reported seeing the ball better, they had better peripheral vision, and they could distinguish lower contrast objects. And not only that, but the batters, I believe these are the people who bat the baseball.
The hitters even.
Well, technical there, Chris. But they had 4.4% fewer strikeouts, so I believe that's when they've missed it or something, which is an impressive drop compared to all the other teams in their league. And they scored 41 more runs than expected over the whole season and showed a lot of improvement in other stats, more than other teams in the league.
Do they know how this works, though? Do they know what's going on?
Well, it's really fascinating because baseball, like a lot of sports, is weighted towards visual accuracy. Obviously, you need to see the ball coming if you're going to hit it or catch it. And what's special about this brain training is that it focuses on training the brain to actually respond better to the inputs it's getting from the eyes in real-life situations and not just making your eyesight a bit better. So it could benefit other players, similar sports. For example, the researchers are starting a new study with the women's softball team. And also they think it might benefit non-sporty types, so improving tasks like reading or driving. But it is worth pointing out that the best visual training in the world isn't always enough. The Riverside baseball team had to forfeit 8 of their wins because they had an ineligible player on the team. So maybe they should have actually read the rules a little bit more closely.
Well, maybe their enhanced vision will help with that. Thank you very much, Kat. Now, the Winter Olympics are currently finishing in Sochi in Russia this week, but it's not just the athletes who've spent the last 4 years training for this event. There are engineers and designers who've also been working to reduce times and to grab golds for their athletes on the slopes. And in fact, when asked about her gold medal in the women's snowball cross, Eva Samkova from the Czech Republic said, "It's just physics, that's all." So to find out why it's just physics, here's your quick-fire science with Kate Lamble and Harriet Johnson.
Friction, air resistance and gravity are the main forces that track and equipment designers working on the Winter Olympics need to consider when they are trying to make times as quick as possible.
In order to reduce friction, skis and snowboards are waxed before use. A professional wax technician has around 500 different products to choose from and selects the right wax for the snow conditions.
When the snow is wet, a water repellent additive called fluoro is increased in the wax. But this can create more friction if too much is added. Anti-static waxes can also be used to reduce electrostatic charges, which can build up over long races.
Snow type has been a problem for some races in Sochi, with snowboarders complaining of soft snow in the halfpipe. By spraying water and salt onto tracks, organisers hope to melt this soft top layer before allowing it to freeze again into harder ice.
Rather than snow, ski jumping tracks are actually made from ceramic. When moistened with water, these have the same friction characteristics as snow, but allow the sport to be conducted all year round in almost identical conditions.
To combat air resistance, special skin-tight suits are worn in a number of sports. However, Team USA have just dropped their newly designed speed skating outfits following poor performances.
There have been some suggestions that vents on the back of the suits, designed to dump excess air, might instead be causing a slight drag effect. While this hasn't been proven, the team chose to swap the suits as athletes were concerned about the possibility of their performance being affected.
In other sports, equipment is also important to help athletes perform at their best. In luge, weight vests can be worn by lighter competitors to minimise the advantage carried by their heavier peers.
In curling, players wear one rubber-soled shoe to allow them to push off from the ice and one Teflon-soled shoe. The Teflon has a reduced friction coefficient and so allows them to glide across the ice.
Commercial companies also help in designing equipment. Great Britain's gold medalist in the women's skeleton had her sled designed by motorsport company McLaren. The designers used computer simulation to make sure it could be adapted to suit a range of different tracks.
That's Kate Lamble and Harriet Johnson, and you can get hold of all our Quickfire Science episodes as their own podcasts from our website at thenakedscientist.com/quickfirescience.
You're listening to The Naked Scientists with me, Chris Smith, and also with Kat Arney. Now, this week, Cambridge researchers identified a biomarker that can point towards having major or clinical depression. This biological signpost could mean that boys who are at greatest risk of depression could end up getting treated earlier. Ian Goodyear led the study. He's at the University of Cambridge and he's with us now. Hello, Ian.
Good evening.
Just back from the Alps, so
Indeed.
hopefully not depressed in your case.
No.
What was the problem you were trying to solve with this study?
Clinical depressions are a whole group of as yet poorly understood conditions. They emerge in the teenage years in the main. Between 13 and 17 years of age, about 1 in 6 to 1 in 10 of young people are going to experience depressions, and about 30% of those are going to be quite severe, taking you to hospitals, GPs, and in some cases to psychiatrists and mental health specialists.
It's a very large number.
It is a large number. But there are many different kinds of illnesses in there. Some of them will only last for a few days or weeks. Unfortunately, some of them will last for many years and very occasionally for the rest of your life. What we don't know is how to spot individuals in the community at large who would be at different types of risks for different kinds of depressions. And people have been trying for some time, perhaps up to 30 years, to find markers in individuals that put them at risk for one or more of these kinds of depressions.
I presume if you have some kind of marker, then you can put people into a different category, and different categories are going to require different treatments or interventions and have different prognoses attached to them.
It would be the aim and objective to get to the kind of paragraph you just summarised. If we can find markers, does that allow us to identify groups at differential risks? Does that mean we can plan different kinds of interventions at the public mental health level, or indeed, as you implied, at the clinical intervention level? Long way to go, but it's about time we started going down this path.
So how have you done this?
Well, for many years we've known that the HPA axis, that's shorthand for the hypothalamic pituitary adrenal axis, releases a hormone called cortisol, which moves up and down at different times of demand on the individual. It's a very important hormone. It's got nothing to do with disease. We need it to stay alive, and it gets into all of our cells all over the place, including the brain. About 40 years ago or so, some scientists in the States and in Europe showed that some individuals who were depressed had very high cortisols. At first it was thought, well, this is just a consequence of being ill, like having a high temperature. And I think the initial excitement died off. But in the last 20 years, people have noticed that morning cortisol levels can be high in some individuals in the population at large who are not ill. And that's intriguing. So we started off over 2 decades ago in trying to figure out if high morning levels on their own were associated with the subsequent increase in onset of any kind of depression. The answer was yes.
What were you looking at, blood or urine levels for this?
Well, you had to do the usual technical work. First, we had to develop an assay that was sensitive and specific enough in the lab. We then had to show that levels in different bodily compartments were correlated with each other. So we did a study which involved comparing CSF, blood and saliva levels in different populations and showed that the levels in saliva were estimable with respect to blood, which was estimable with respect to the CSF levels.
CSF, the cerebrospinal fluid, the fluid around the brain.
The fluid around the brain. And what that meant was that we could take saliva levels in the population at large and make some degree of interpretation about its implications for the brain. Now that took 2 decades, and then the study that we just published in the Proceedings of the National Academy of Sciences and funded by the Wellcome Trust, that took a decade. So we needed approximately 1,850 teenagers in 2 slightly different studies. The second thing we needed, which has not been done before, was we needed to do this longitudinally.
So you need to know, does one beget the other subsequently? If we have one at one point in time, do you then get the depression or the other illness later?
That's right. There's a bit of important mathematics because you have to try and establish longitudinally over 12 to 36 months the relationships between depressive symptoms themselves and the relationships between different cortisol levels themselves. Then you have to put the 2 together. And that's how you create different classes in the population at large.
What have you found?
So about 17% of the teenage population had both high long-term depressive symptoms, not clinical, just the kinds of things you and I were talking about, and high long-term morning cortisol levels. So when you were in the group with the high depression, high cortisol level bit, and you were a boy, not a girl, that's an interesting and slightly surprising finding, then your chances of being depressed over the coming months were about 14 times higher than either boys or girls in the rest of the population.
Which I presume means that we now have an opportunity to use this as some sort of screening test in order to identify people who might be at major risk.
Absolutely. It's ironic that about 25 years ago, GPs asked me if there'd ever be a screening test using cortisol. I said I wasn't sure. Well, here's our chance.
Ian, thank you very much. That's Ian Goodyear. He's from the University of Cambridge, and as he said, he published that work this week in the journal PNAS, so many congratulations to you. Kat.
Now, one story that I've seen is about platelets. Now, when you cut yourself, little tiny blood cell fragments called platelets rush to the rescue. They help your blood to clot, they help your wounds to heal. They're absolutely vital as a treatment for people hurt in accidents and those with certain blood diseases where they don't make them properly. But you can only get them from blood donations. And as any doctor will tell you, there are never enough blood donations, especially because platelets actually have to be kept at quite specific room temperature and they have a very short shelf life. But this could be about to change thanks to an important new paper from Dr. Koji Ito and his team in Japan published in the journal Cell Stem Cell. And in it, they describe a completely new way to create platelets from stem cells grown in the lab, potentially reducing this need for donated platelets in the future.
How have they done it, Kat, and why couldn't we do it before?
People have tried this before, but they've just had a really poor yield of it. And the technique that other researchers and the Ito team have used is a recently developed technique that we've heard a lot about lately. It's so-called induced pluripotent stem cells, or iPS cells. And this is a way of turning adult cells into stem cells by adding a handful of protein factors. This is the discovery that won Japanese scientist Shinya Yamanaka a Nobel Prize a couple of years ago. Now, the team in this case treated these iPS, these reprogrammed cells, with another cocktail of genes that converted them into a type of cell called a megakaryocyte, which sounds brilliant, megakaryocyte. This is a very large precursor cell that produces platelets. And the platelets from these converted cells, they just seem to be like regular platelets. They clotted in the same way and everything was fine. Now, the key thing here is that it looks like you can actually freeze down these reprogrammed megakaryocytes because you can't freeze platelets. So actually, if you could start freezing them down, if you can grow them on a large scale in the lab or in bioengineering facilities, you might even one day be able to have platelets on tap. And that's a really exciting and potentially life-saving for many people idea.
Sounds encouraging. Well, related to wounds that might make you bleed, there's also a paper this week, it's in the journal Science, where researchers have managed to make artificial growth factors that will stimulate wounds to close. This is Jeffrey Hubel and his colleagues. They're at the École Polytechnique Fédérale in Lausanne, in Switzerland. And what they did was to say, well, we know of these growth factors which, when you injure tissue, ooze out of the injured site, and they stimulate cells locally to begin to proliferate and grow, to heal up a wound, make new blood vessels, bring in stem cells to make good the repair. But if you try to speed up repair by adding these growth factors, then they tend to go elsewhere in the body and produce lots of side effects. So wouldn't it be good if we could tether them just to where we need them? And they've done a cunning piece of work where they went and looked at various places in the body to see if they could find proteins that can act as anchors. In other words, they can glue things to tissues. And well, lo and behold, they looked in the placenta and they found this growth factor that's normally only present in the placenta, the thing that effectively links a baby to its mother. And in there is a placental growth factor, but it has a special anchor on this growth factor that locks it into the placenta. So they stole this little piece of the protein. They took the gene for that, coupled it to the normal growth factors that we know about working in tissues called things like PDGF and BMP and VEGF. They have various names for them. And what they found is that they could drip these new growth factors coupled to this sticky anchor into a wound in, say, a mouse. And the wounds would close 4 times faster in these mice. And they could do this with doses that were just 1/250th of the amount of growth factor you'd normally need to add to get that equivalent rate of healing. So it looks like you can do all this and not have any of the side effects by making these artificial growth factors that just stay where you want them to go.
That's incredibly powerful. You could imagine like some kind of glue or plaster that delivers them.
Yes, you could have some kind of patch that oozes them just into the wound, and they'll go into the wound and stick themselves just onto the wound site, and they can't go anywhere else in the body.
Thanks, Chris. If you'd like to follow up on any of the stories we've been discussing, there are references and transcripts for those news items on our website at nakedscientist.com/news.
You're listening to The Naked Scientists. I'm Chris Smith, and also here this week is Kat Arney. In a moment, we'll be going into our main topic for the week, which is the subject of norovirus, the dreaded winter vomiting bug. Just to remind you, though, we have our quiz running this week. We always ask you a scientific teaser. We're asking you, if you took a norovirus and you scaled it up to the size of a grapefruit, how big would the corresponding person be that it would be infecting? How big would that person be? If you think you'd like to speculate, and wild answers are welcome, email chris@thenakedscientist.com, or you can tweet @nakedscientists. We're also interested in any questions or comments you have about the subject of norovirus, because we have this week assembled a panel of experts. In a second, we'll hear from Ian Goodfellow, who's Professor of Virology at Addenbrooke's and in Cambridge University, and he works on norovirus and trying to understand how it causes disease. We'll also hear from Lydia Drum-Wright, who's starting a new project to look at how noroviruses get round in the community and get round in the hospital. We'll find out practical tips on how you can stop norovirus spreading in your home and in your hospital from Rachel Thaxter, who's the infection control lead at Addenbrooke's Hospital. And we'll also look at the cost implications of noro. What does it do in a health service setting? Keith McNeil is the chief executive of Addenbrooke's Hospital, and he'll be explaining more about it. First, I caught up with Ian Goodfellow earlier this week to find out what actually is norovirus.
So noroviruses are small, highly infectious viruses that cause gastroenteritis, and they're typically referred to in the public press as the causative agent of winter vomiting disease. But outbreaks occur all year round. The reason they're referred to as winter vomiting disease is simply because of the peak incidence appears to occur in and around the winter months.
Why is that?
It's probable that they tend to survive longer in the environment, in the cold and wet, but also people tend to spend a bit more time together during the winter. The reality is we still don't know. It's one of the very important questions that need to be addressed for noroviruses.
And when you say the agent lurks in the environment, give us a sort of a snapshot view. What do these viruses look like, and how do they get into the environment?
So these are tiny, tiny little viruses, one of the smallest viruses around. The virus coat, or the shell, is made up entirely of protein. So this makes them particularly resistant to inactivation by detergents and things like that. They get into the environment primarily through the vomiting or through the diarrhea episodes that people would have, and they get into the sewer systems and they contaminate the water courses. They often will also contaminate shellfish, and people will get norovirus infection from eating contaminated, uncooked shellfish.
And when you say that it can stay in the environment, how long, if a person is symptomatic in an area, how long will that area retain virus that's capable of infecting someone?
Probably in the region of between 7 to 10 days, if not longer. If it's untreated, there's probably going to remain enough infectious material there to infect somebody for at least a week. And this is partly because you need to be exposed to very few number of particles to become infected. So less than 20 particles are thought to be enough to cause an infection.
And when a person is symptomatic, to put that into perspective, how much virus are they shedding?
An individual would normally shed somewhere in the region of 1 million or more virus particles per milliliter of feces or vomit, and you need only 20 to infect an individual. So each infected individual can infect many million others.
Wow, it's amazing to think there's millions of infectious doses in every single person, isn't it?
Absolutely.
So when I ingest norovirus, I've got to pick it up from the environment. It presumably gets either onto the food I'm eating or onto my fingers and gets into my mouth, and I then swallow the particles. What happens next?
So it's a very good question. In fact, we don't really know much about the life cycle of noroviruses, particularly in the gut. So, for example, we know it grows in the intestine, but the reality is we don't know precisely what cells in the intestine it infects. What we do know is it basically mimics the body's response to eating something that was poisonous. It stimulates this response known as the emetic response, where effectively your body will eject all the contents of the stomach. And this is the vomiting episodes that you get, and then you will flood the intestine with fluid to try and wash out any poison. And we think what the virus is doing is stimulating this process either directly or indirectly by interacting with certain cells of your nervous system.
What about other animals? Because people often ask me, can my dog give me diarrhoea? Do we exchange these infections with animals, or is this purely a human infection?
This is a very good question. Norovirus has been identified in a whole range of animals, and there appears to be very specific noroviruses for cats, for dogs, for cows, for pigs, for example. But there is limited evidence now that human norovirus can be found in the pig population. Whether or not there's a zoonotic transfer from pigs to humans is not entirely known. And in fact, there's limited data as well to say that in some cases human noroviruses can be found in dogs. And this is something that we're working on in my lab to try and see if this is a common occurrence. At present, we think that human noroviruses are not a zoonotic disease, so they primarily infect humans.
And when I catch it, am I immune to it almost immediately that I've caught it? Is that why the symptoms go away? Because the symptoms do go away pretty quickly. Within 48 hours, you're feeling right as rain again, usually, aren't you?
You are, that's right. But it's likely you don't generate a very good immune response. And we think one of the reasons these are such effective pathogens is simply because you don't generate long-lasting antibody responses to this virus. And it's more a process known as your innate immune response that clears the virus. So the virus is not there for very long, therefore you don't generate very good antibodies. So you can be reinfected probably once every year by the same virus.
Gosh, and are there also lots of other strains circulating? So although I've had one type previously, I may in fact pick up another next week to which I have no immunity and I can go down with it again.
Yes, again, so one of the features of these viruses is that every time they multiply or copy their genetic material, they make mistakes. And this means the virus can evolve very rapidly. Typically in any 1 year, you find that there are at least one dominant strain or isolate of norovirus, but that will evolve. There'll always be minor species within that. And in fact, within any individual who's infected, whilst it may be one strain of virus, each individual virus particle will contain a slightly different sequence. And this gives the virus the ability to evolve away from any immune response.
And does that frustrate efforts to make a vaccine then?
This causes a lot of problems with the vaccine production. However, there's very encouraging data coming out from a company known as Takeda. Their data suggests that you can protect from infection if you immunize individuals with the same type of norovirus strain, and that will protect primarily from symptoms. So less than 50% of individuals will develop symptoms, and this can prevent spread. It's likely, though, if norovirus vaccine becomes viable, it's likely it will need to be changed every year, very similar to the influenza virus vaccine. However, us and a number of labs around the world are trying to develop new vaccines that give cross-protective immunity. Probably in the next 5 to 10 years, they'd be looking at larger scale trials of human norovirus vaccines.
Thank you very much to Ian Goodfellow from the Department of Pathology at the University of Cambridge.
So we've just heard how norovirus affects people, but how does it spread? We're joined by Lydia Drumright from Imperial College London. She's undertaking a new study to find out how the virus infects people and how long they remain infectious for. Hi Lydia, thanks for joining us.
Hi, Kat.
So tell us a little bit about what do we know so far about the life history of norovirus, how it infects us and where it goes in populations?
So we actually don't know a lot about that. There's a number of studies that have been conducted looking primarily at the strains that Ian talked about, the predominant strains in Sydney that people may have heard of recently, which was last year's strain. But one of the important factors is that we only look where people are symptomatic. So where people are part of an outbreak, those are who are collected into studies. And what our study will look at is not only those people, but all the people around them, because we're concerned that people are becoming infected and shedding without actually being symptomatic.
So the main way that you get rid of virus from your system is by vomiting and diarrhea. How could people just shed the virus when they're not having severe symptoms?
So the thing about infectious diseases that we're learning is that actually we have what we call carriage and we have what we call infection or symptoms. And so you don't actually get rid of the virus by vomiting or having the diarrhea, as Ian had mentioned. You get rid of it by an immune response. And so the process of shedding the virus happens whilst it's in your body, and different people have different immune responses.
So effectively, you can be not vomiting, not having diarrhea everywhere, but you can still be dispensing virus to your family, your friends, your colleagues.
Exactly, secretly dispensing virus, if you will.
So what are you trying to do with this study? As you're studying it in people and populations, are you also trying to find out, where does it hang out? As Ian said, it can hang around in the environment for up to 10 days.
Exactly. So we're using hospitals as sort of our microcosmic environment, if you will, and we're swabbing the ward areas. So people have done this after there's an outbreak and they see lots and lots of norovirus. We want to swab all year round, so we're doing weekly swabbing to see when it's there, if it's there, where it's hiding out, and also looking at the symptomatic and asymptomatic people.
Do you have any idea of the kind of patterns that you're looking for?
So what we're looking for, and we might be hoping to see, is that actually environmental swabbing will tell us when we should be expecting outbreaks in the hospital. So in other words, we might not see any norovirus, or we might see it at a very low level. And then as that level increases, we wonder if that will lead to outbreaks or not.
The results from that could be really powerful for hospitals trying to cut down on infections. It surprises me that this kind of thing isn't done already.
I would agree with that. I think that there's been a lot of challenges to funding environmental studies, and this was the one question I think reviewers had on our study as well. They said, well, I'm not sure how strong of a component the environmental is, but we like the rest of the study, so go ahead and fund it. But actually, I think the environment is very important. We talk about it a lot for MRSA and other infections that we know about, and we just don't know how it's playing a role.
And it seems quite sobering as well that, as Chris said, the advice is once you've had norovirus, after about 48 hours, you're feeling okay again. It's quite sobering to think that people could be infectious for much longer than that. Do you think that that should change advice on what people should do?
At the moment, I would say no. So we do know from previous studies where they infect people deliberately, healthy volunteers, with norovirus, that the average healthy individual sheds for up to 3 weeks. What we don't know is how infectious that shedding is and how that contributes to the environment or further outbreaks. So at the moment, we should probably stick to the guidelines because we don't want healthcare workers certainly off for 3 weeks. That would cause a huge problem for the NHS.
Well, especially if people are feeling fine again after 2 days, I guess. Thanks very much. That's Lydia Drumright from Imperial College London.
You're listening to The Naked Scientists. I'm Chris Smith, and also here this week is Kat Arney, and we're talking about the science of noroviruses, the winter vomiting bug. Don't forget, we're also including your questions in this programme, so if you'd like to ask anything about noroviruses or infection control, how do we mitigate the spread of them, email chris@thenakedscientist.com, or you can also tweet at Naked Scientists. Now we're going to be talking to Rachel Thaxter, who's actually infection control lead for Adam Brooks Hospital. And she's brought along some kit because we're actually going to try to show how bad people are at hygiene. Rachel, hello.
Hi, Chris.
Tell us about this gadget.
This is a gadget we use in hospitals to teach student nurses and medical students how to wash their hands. We use a cream that's got a UV impregnated particle in it, and we ask the staff to put this cream onto their hands and rub it in like a hand cream all over the surface of their hands and their nails. We then ask them to go and wash their hands and see how successful they are at actually washing this cream off.
Because if they were potentially infectious for norovirus or had contacted a surface with norovirus, hands are presumably the main route via which infection spread.
Yes, hands are key in all infections, really. So good hand washing, good hand hygiene at all times is what we recommend.
Well, I found you a victim, Harriet Johnson, who's here with us from the Genetics Society. How's your hand washing? Up to spec?
They look pretty clean. They look all right.
OK, what do you want us to do, Rachel?
OK, I'm just going to put some cream onto Harriet's hands. So just nice splodge of that all over your hands like a hand cream, your nails, your wrists, your thumbs.
So this is called Glow and Tell. So this is just a dye which will glow under UV, the idea being that you're going to send her off to wash her hands.
That's correct, yeah.
And if she misses bits, we'll know.
We will, yeah. It's not actually highlighting the bugs on her skin, it's just like a cream which we then wanted to try and wash off to mimic the possibility that we have all these bugs on our hands. And Ian said there's thousands of them, so off you go and wash your hands.
OK, Harriet, so if you go and wash your hands now, as you would do normally, right? So just how you would judge your hands to be clean after washing them. So you've been to the loo or something. I presume you wash your hands after going to the loo.
Always. Never
Good.
A walker.
We'll see you in a minute. So, Rachel, what sort of practical tips can you give people if someone goes down with DMV in their house? What's the best way of someone not spreading it round the family?
Isolate yourself, so stay in your room. If you've got the luxury of having many toilets in your house, then try and allocate a toilet to the sick individual with their own hand washing basin. If you haven't got that luxury, then making sure that the affected person has their own towels and flannels. There's no sharing of those kind of items. Keep yourself hydrated. We don't really want the sick person preparing meals for the family. Obviously, if that's vital, then scrupulous hand hygiene would be needed. Keep yourself segregated until you're well. And as we've said, that normally is within 1 to 2 days. And then you can start getting things back to normal within your lifestyle. And that's why, really, when you come into hospital, we ask you not to come if you've been unwell and not to come if you've been unwell in the last 2 days. We don't want the community bringing bugs into the hospital and then giving it to our vulnerable patients. And at the moment, we've only got, I think, 2 or 3 cases in the hospital at the moment, Chris. So we know it's out in the community and we want to keep it that way.
What about the clean-up, Rachel? Because we hear a lot about people saying, I use alcohol hand rubs and that kind of thing. What practical advice can you give people for A, their own hand hygiene, and B, cleaning surfaces where someone has been unwell?
Alcohol gels are really good in hospitals when we've had sort of social contact with patients. We're not dealing with patients who are unwell or dealing with their body fluids. And really in the home, I only use hand gels if I'm out on a picnic or somewhere where I can't actually wash my hands properly. I don't use it as a substitute to washing my hands. So in the household, good old-fashioned soap and water is the best thing.
Because I did read that those alcohol gels are actually no use against norovirus. Because like Ian was saying at the beginning, it's a particle that doesn't get broken down by alcohol.
That's correct. So again, we actually not to use as in hospitals when we have problems, and as I say, not to use them at home really as a hand hygiene product.
Mark has got in touch and says, how long does it take for symptoms of this to come on? And I'm surprised I've not caught it from spending time on underground trains that are packed with people from around the world.
It's pretty rapid, I think, as we all know. If we've looked after people with it, people can feel fine at 10 o'clock in the morning and then by 11:30 they're actually vomiting and feeling really unwell. They tend to look a bit grey and ashen, so there's a bit of a giveaway then. But I say normally the patient can be quite well and then suddenly they'll just be unwell. So you may well have to clear up at home. And again, good cleaning. You can use sort of bleach-based products are good for cleaning up body fluids. If your clothing becomes soiled or bed sheets, then wash them on a hot wash and again do them separately to the rest of the family.
Our hand-washing victim, Harriet, is back. Did you do a good job, do you think?
Yeah, I did what I regularly do.
You would judge your hands to be clean. Rachel, what's the verdict?
Just pop your hands under my UV box, Harriet. Okay, so we can see actually that the areas that Harriet hasn't washed quite as well as she thought she had are glowing nice and bluey white under my UV box.
All the backs of her hands.
The backs of her hands.
Where her watch is.
Yeah, you can see where her watch is, which is why we don't wear watches in hospital or bracelets, because we need people to be bare below the elbow so they can wash their hands
properly. Too much
properly.
bling, Harriet.
Quite a lot as well around your fingernails there. So again, these are areas we find it difficult to wash. And also, Harriet's shown me quite nicely that her thumb on her less dominant hand is pretty well covered, whereas her other hand is quite good. So if you're right-handed, you'll wash your left hand really well. But if your dominant hand is the one you're going to be doing all the things with, and that's the area, unfortunately, we don't wash as well. So there's quite a big difference between Harriet's right and left thumb. And as Chris said, actually, you've got loads on the back of your hands, Harriet, there. You've done quite well on the front of your hands, but it's really just showing up all the sort of nooks and crannies where bugs can be hiding. And also, if your skin is quite dry, like it is in the winter, then, again, these are areas where bugs can hide quite happily.
I suppose it's worth emphasising, as Ian Goodfellow pointed out, the infectious dose for norovirus is 20 particles, and each person's shedding millions and millions, enough in fact to infect the entire world from one infectious person. And any patch of Harriet's skin could have easily an infectious dose of noro.
It could, yeah. What do you think, Harriet, about
what
that?
do you think about? Are you shocked?
Yeah, I'm filthy.
Well, we know that, but I mean, were you quite surprised at the finding?
Yeah, I mean, there were ones that I was expecting, like the back of the hands. I always think people don't pay attention to that, but I did find the difference between the two hands themselves is one of my hands is dirtier than the other one, so I'll change the way I shake hands next time.
Rachel, one quick question, thank you, Harriet, from Jonathan Bowman, who got in touch and has said on Facebook, is it true that it's virtually impossible to eradicate norovirus from surfaces without resorting to industrial-strength bleaches, presumably and hopefully not?
I mean, again, good soap and water, so good basic cleaning you have in your household. I'm not sure whether Lydia knows any more than that, but generally, infection control is all about good hygiene and common sense. So what do you think, Lydia? Can you help me out there?
So actually, in studies where they were cleaning wards and then swabbing afterwards to identify whether or not they cleaned well, they actually did show that a bleach type of 10% bleach solution plus additional soap and water washing was what was required. So my guess is it's repeated washing if you can't use a 10% bleach solution.
Thank you to both of you.
Well, now we've heard how norovirus can spread and how difficult it is to wash your hands properly. How do hospitals protect their patients, and how much does it cost them every year? To find out, we're joined by Keith McNeil, the Chief Executive of Addenbrooke's Hospital. Hi, Keith.
Hi, Kat.
So tell me, for you, running a major hospital like Addie's, what are the costs of norovirus?
Well, that's a very complicated question, and it's multifactorial. So in principle, any illness that adds the complication of admission of a patient to hospital adds additional cost. If it's a young, healthy adult and you get norovirus, it may lengthen their stay by a day or so, or they may be able to be discharged appropriately. But if you're frail and elderly, or you have an immune disease or complicated surgery, your stay in hospital can be lengthened quite significantly. If you're on the intensive care unit, it can be devastating. So it's difficult to quantify in absolute terms. The other thing is, of course, once we get norovirus in the hospital in significant numbers, we have to escalate to stop it from spreading, and that can mean isolation of patients or even closure of entire wards or bed bays to stop that virus from spreading. That then has flow-on effects in terms of our ability to do the work that we're set up to do elective surgery, to service the emergency room and flow patients through. And we have a problem then in generating the income that we need through that activity. So a big outbreak can end up costing us hundreds of thousands of pounds.
And I guess also there's a risk that your staff would get it too, and suddenly you find yourself with no doctors and nurses.
That is a big risk, and I think that's been pointed out by the two ladies on the panel, that infecting the staff and knowing how long they're going to be shedding for and potentially spreading it further is very important to us.
Now, Addenbrooke's is doing quite well, I understand, in terms of keeping norovirus out. What's the worst you've ever seen it there, and what do you think is the secret to your success at the moment?
Well, I've only been at Addenbrooke's for 12 months now, but I do understand that a couple of years ago, I think there were 5 or 6 wards closed, which is a tremendous burden on the hospital and on the whole community. So whenever that sort of thing happens, we've got escalation protocols to try and lock it down as quickly as we can and prevent it spreading further. Deep clean the wards. We highlight the need for people not to turn up if they don't have to, restrict visitors, etc., etc.
And what do you think, if you could tell people listening to this, what are the key things that the public can do to help you keep Noro out of the hospitals?
Well, whenever they come into the hospital, make sure they wash their hands when they come in, when they go onto the wards and when they leave the wards. So hand washing has been highlighted as being very important in controlling this infection.
And I guess the irony is, if you actually have Noro, the last place you should go is a healthcare facility like your GP or a hospital. If people have it, they should just stay in, I guess.
Well, if they're otherwise well, yes, they should. It's usually self-limiting in healthy people. If you're otherwise unwell, of course, sometimes you just have to turn up and receive care. But certainly if you've got these self-limiting illnesses, you should try and stay away from other people, and particularly from health facilities whenever you can.
Thanks very much. That's Keith McNeill, the Chief Executive of Addenbrooke's.
Don't forget, we're also asking you, if you scaled up a norovirus from its present size to the size of a grapefruit, how big would the corresponding person it was infecting be? We've got some quite interesting answers. Pat Kingston says Jupiter. Les says the city of Cambridge. And also we've heard from Ed Wilson, who's emailed in. Chris at nakedscientist.com says about 2 times the diameter of the moon. Still going for pretty big things. What do you think? You're listening to The Naked Scientists. I'm Chris Smith, and also here this week is Kat Arney, and we're talking about the science of norovirus. We have Rachel Thaxter from Addenbrooke's Hospital. She's an infection control nurse. We also have Keith McNeill, who's the Chief Executive of Addenbrooke's Hospital, and also Lydia Drum-Wright, who's doing a study at the moment, actually looking at how noro spreads in the community to try and understand how long it loiters for. Let's look at some of these questions. So Android Neox says, Rachel, are there any gels that can kill or destroy viruses? What about using hydrogen peroxide? Is that a good option?
Well, you can't put hydrogen peroxide onto your skin, of course, but we do use that in a vapour form when we're cleaning our wards. Keith talked about deep cleaning. We do deep clean areas that have had norovirus outbreaks or side rooms that have had patients with infections in them. So we do quite robust cleaning at Addenbrooke's using the HPV process. But say you can't get those products onto your skin. They're highly toxic in higher concentrations. But in the vapour form, it's a very small amount of agent that's there, and it's very effective at cleaning our environment. Some of the gels do claim to be effective against flu virus and things like that. But as we've said, really, although they say they are, it's always the best gold standard to wash your hands if you've got that facility. So gels, I say, are useful in hospital for social interaction with patients, and really useful if you're in a situation where there isn't hand washing facilities, such as on a picnic or family holidays and things like that. But we generally say, although they say on the label, we will kill viruses, we generally say we shouldn't rely on that.
We've got an email here from Josephine Ong, who says, how does the body actually fight off noroviruses, and are there lots of different strains or kinds of it? Well, Ian sort of suggested that there are strains, but could you tell us, Lydia, a little bit about how it goes around the world and changes?
So one of the things that we've noticed with norovirus and all the sampling that there is there are a number of different strains. We call these genotypes of norovirus, and there are also genogroups, so this kind of a wide variety. And as you mentioned, Chris, you could be presumably infected twice in a year or even in a short period of time by 2 different strains, although, as was mentioned, there are predominant strains that circulate. Now, these move around the world quite rapidly. Looking at all the data that there is in GenBanks, that's everybody's analysis of the virus from the genetic material in the virus, we can see the same virus moving for 10 to 20 years and spreading within the same year from the US to China, from the UK to Southeast Asia. So really quite rapid spread.
And Keith, if Lydia's results show that people are infectious for 3 weeks, what's that going to do to your budget if you have to put the staff off work for 3 weeks?
Well, I think it'll come back to the evidence as to what that actually means, because we control outbreaks now without having staff off. So the question, I think, is how does that shedding actually translate into the spread of disease? We don't know that at the moment, but we'd be guided by the evidence. If it has implications, it has implications, and we have to plan for that.
Thank you, Keith. And Rachel, just very briefly, Mark has emailed in to say if he has norovirus, how long does his flat remain infectious for? In other words, if he's planning a dinner party, how long should he defer the dinner party for in order not to infect his guests? What do you think?
Well, at least for 48 hours.
I don't think he's implying he's going to cook dinner while he's having diarrhoea and vomiting. But
well, hopefully not.
How long should people not come round your house for?
If you're really good at cleaning, perhaps a week. Clean your house a couple of times, your bathrooms, the key areas, your kitchen, a week.
Okay, so defer that dinner party for a week, Mark, and you'll probably be all right.
And finally, to close our show, Hannah has our question of the week.
This week, we zoom in and try and get our brains around this.
My name's John, and I'm calling from Belfast. I'd like to know why MRI imaging is so low quality. Why are the images so blurry? And how long will it be before we can get accurate, sharp imaging of the brain and the tissues inside the head for correct diagnosis of diseases?
So whilst it might appear that MRI, or magnetic resonance imaging pictures, are blurry, in fact, they are not, as Paul Thompson, Professor of Neurology at University of Southern California, explains.
Right now, the scans we use in a hospital can see small strokes and blood vessels as small as 1 millimetre in diameter. The detail is terrific, and brain scans can help diagnose cancer and Alzheimer's disease. The detail you can see depends on how long the patient can sit still in the scanner. It can take 5 to 10 minutes to get a brain scan, and we can check parts of the brain involved in memory, language, and emotions. With a method called functional MRI, we can also see which parts of the brain are active while you're looking at a picture or speaking. Normally, it's hard to sit still for more than about 10 minutes, so scientists are working on faster methods to speed up brain scans and get more detail.
So even though we can use MRI to take detailed pictures of brain structures, functional, or fMRI, looks at the activity of different brain areas by measuring how much oxygen they are using. But because the brain is moving and many measurements are taken over a period of time, the activity maps that fMRI produces tends to be of lower resolution, which might explain why John refers to the images as being blurry. So what about imaging to diagnose brain disorders?
Brain scans are often used in a hospital to see if a person's brain is damaged, if they've been in an accident, or if they have memory loss that could be a sign of Alzheimer's disease. Also, if a person has a stroke or a brain tumour, we can see clearly what parts of the brain are affected, and we can see if a treatment is helping. Brain scans can also be used to plan a surgery that takes out a brain tumour while protecting the rest of the brain.
And Paul is also part of one of the largest brain studies in the world. Called the Enigma Project, 307 scientists have scanned 27,000 people's brains, including individuals with psychiatric conditions, and the results suggest that brain scans, like MRI, could be useful for distinguishing between schizophrenia, bipolar and depression in the future, and these disorders can sometimes be hard to tell apart clinically. So this finding may help to diagnose people sooner so that they can receive the correct treatments early on. Thanks to John for the question and Paul for the answer. Now, keeping our brains alert, Hazel Barraclough wrote in with this.
Hi there. Can you tell me why it is that when lightning strikes the sea or any other large body of water, it doesn't kill the fish? Many thanks.
So why don't we see floating electrocuted fish following a thunderstorm?
A fishy problem. If you know why, email chris@thenakedscientist.com. You can Facebook us at Naked Scientists or get in touch with us via Twitter. We're @NakedScientists.
Now to our teaser this week. We asked you at the beginning of the programme if a norovirus were inflated to the size of a grapefruit, how big would the corresponding human victim end up being? Well, many of you have speculated on the scales of planets. We've even heard a late entrant from James Carrington on Twitter who says roughly the size of the moon. Well, you're not far adrift, because here's how it breaks down. A norovirus is about 30 nanometres across. That's 1/30,000th of a millimetre, give or take. A grapefruit's, 10 centimetres, which is about 100 millimetres. So if you times 100 millimetres by 1/30,000th of a millimetre, that means you've basically made your norovirus about 3 million times bigger in order to become grapefruit size. So your human, given an average human being 2 metres tall, would therefore be 6 million metres tall, or 6,000 kilometres, which is roughly the same as the radius of the Earth. That's it for this week. Thank you very much to our guests, Ian Goodfellow, Lydia Drumwright, Rachel Thaxter and Keith McNeil. Thanks to Katani for joining me, and to Kate Lamble for production. Next time we're going to be at the Cambridge Science Centre for a live show where we'll be discussing robotics, including artificial intelligence and how machines can understand human language, plus how we use robots to explore outer space. Send your questions in if you have any to chris@thenakedscientist.com. The Naked Scientist is supported by the Wellcome Trust, the EPSRC and the STFC. My name's Chris Smith. Thank you very much for listening. Goodbye.